All right. Testing, 1, 2, 3. Sounds good. All right, I've got my scalding hot peppermint tea. I've got some frigid Pepsi Max vanilla on the rocks, and some room temperature water. So I've got all 3 drinks ready to go. I really should set a scheduled time, I think, in the future. But oh well, this is good. So, I gotta minimize myself on the other screen, otherwise it's distracting. Just look at the chat. All right, cool. I can take my headphones off and we can get into today's topic. So if you haven't seen these streams so far, we've been building a programming language here. Everything is on stream so far from start to now. And we can successfully parse and emit the assembly code for something like this. This is a main procedure assigning a bunch of variables. We can also parse expressions like x plus y, for example. This is kind of bothering me. There should be a space. Well, there doesn't have to be a space, but that looks a bit better. And we can do some other things. If I could open files. You know, more complex expressions with parentheses, divides, etc. Now we can't emit all of these into assembly at the moment. I don't think we even handle the divide case, right? Oh no, we do handle divide. Divide's a little bit complicated in x64 assembly because it puts the remainder and the quotient into set registers, so you've got to actually handle that case. It's not like an addition where you can just choose the destination register. And, you know, we've got a bunch of other things we can parse. We can parse all of this stuff, but we can't actually emit the assembly for calling procedures like add here. So that's what we're going to do today. I'm going to make a new fixture. Fixtures, I'll just make this 08. That's already one that we have. Okay, I'll make it 09. Okay, and we'll just make a main procedure. It's going to return, I guess we'll return a signed 32-bit integer. The reason we return a signed 32-bit integer is because we're on Windows, and this language is going to emit, if we go to, where is it, exit process, we're going to actually emit the Windows Win32 procedure exit process, and that's going to be the return code that we pass into this. And then so we can check that after we run the program to see whether it correctly returned the right value. And that is it's actually a uint. So it should be U32, I suppose. All right, so we'll have our main procedure here. And we're going to just try and add. So we'll add 2 numbers together, 2 U32s, I guess, and return a U32. Oops, return x plus y. Oh, we've got return working on the last stream as well, so we can return values. That's all well and good. And so what we really want to do here is basically just say return add 2 numbers together, A and B perhaps. And we're going to say A is going to be unsigned 32-bit integer of the value of 40. B is going to be 2, standard 42. All right. Okay, so the target for this, sorry, for this stream is to make the assembly look good for this. So if we go over to our main file here, and we just type in fixtures 08, run the code, let's see what happens. All right, so there's a bunch of output here. If you haven't been watching the stream so far, it might be a bit confusing, but basically we've got all of the tokens. So we've scanned over the source file and we found, for example, the U32, we found an equal sign, we found a number 2, we found an identifier called return, because at this stage we don't know that that's a keyword yet, because we haven't parsed it in the language so far. It's just finding different identifiers. I mean, I guess you could do it at this stage, but we don't. Then there's some output here from the lowering stage where we're reserving registers to put stuff into. And then we've output, this is the intermediate representation. So these are our instructions. We've got subtract, move, add, move, return, and etc. Procedure declaration. And this is the assembly that it outputs. So we've got this hard-coded start, which always calls exit process and then calls into main. And main is what we defined here. So we're allocating some space on the stack for the Windows calling convention. You need 32 bytes of space, and then you need to align the stack to 16-byte boundary. So we need to check this in the debugger shortly to see if it's actually aligned. And that's only if you're going to call another procedure. So this is actually invalid assembly. You can see this move RAX and then there's nothing here. That's not correct. And we're missing the call, so there's no call, right? So it just says add RSP40, which is not correct. But as you can see here, we've got add, and once again, we're missing some values. So we've got a few bugs. And then finally down here is the abstract syntax tree printed out. I think it's got everything. Sometimes I forget to add things. It's a little bit messy at the moment, but this is basically saying, okay, I've got the file that we're in, and then there's two procedure declarations. One of them is called add, one of them is called main. This one returns U32, this one returns U32. Add is a leaf procedure. That means it doesn't call any other procedures. And then all we do is we have these parameters, X and Y, U32. We've got a block. We return a binary operation, which is addition of two numbers, X and Y. Okay, I think that's pretty straightforward. And then procedure declaration, we've got a block again, of course. And then we've got a variable declaration, which is A, it's a U32, and it's got the number 40, B, U32, number 2. And we're going to return the result of this call, which is calling add and passing in these identifiers. So really the problem that we're having at the moment in add is that we have no way to refer to the parameters that are passed in. So you can see we're correctly moving into RCX and RDX 40 and 2. And why we're doing that is because those are the integer registers for parameter 1 and parameter 2 of a function. So in this case, that's parameter 1, X, and Y is parameter 2. So we need to move these into RCX and RDX. That's correct. But then in our procedure, we're not reading RCX and RDX. So this is wrong. So we've got to have a look at how we're emitting the code for procedures and take into account that they might have parameters or arguments passed in. So let's have a look at procdecal somewhere in this file. Here it is. Okay. So what we're doing is we're resetting this local, like the compiler's stack offset here. And then what are we doing? Appending an instruction, which is a procedure declaration. So what that actually does in the assembly, if I open out.asm, that basically just prints this line here, add. So procedure declaration takes the label text and then it will create this line here. So we can have the name. And then we say if it's not a leaf, we want to make a binary instruction here. And that's to subtract the shadow space, which we need for the Windows calling convention. In this case, we're doing 40. Sorry, no, we're doing 8 because it's not, because it is a leaf, rather. So if it's not a leaf, we do 40. If it is a leaf, we do 8. Really, I should swap these around because It seems a bit strange to have a not, a negation, and then an else. Right? It's just the way that I wrote the code was I did it the other way around. There was no else case at the beginning. And let me just see if I can control, what's the hotkey? Control W, and then greater than, okay, yeah. So I need to do like 20, control W greater than, there we go. All right, a little bit more space here. Maybe even a little bit more. Yeah, that's all right, I think. Cool. So now we can look at that, and we can look at the fixture. That's all good, there's enough space. Could even maybe have a little bit more. Luxury. Cool. So after we allocate this stack space here, we're then saving, this is sort of my convention, I don't know how people usually do this, but I'm saving RBP, which is base pointer, I think that's what it stands for, which on Linux it's actually updated automatically, I believe, but on Windows they just ignore it. So we're saving it because we might need to restore it because it's non-volatile. That just means you have to restore it after you use it in your procedure. So we're saving that to the stack, and then I'm going to set it, this base pointer, to the current stack pointer. And the reason I do that is so that any variables we make, like for example x, y, z, and etc., if we use up the registers, we can then start adding them to the stack, and we can just save the offset from RBP, which I find is a much easier way than trying to, I don't know how else you would do it, like dynamically figure out the size of the stack now versus when you allocated the variable. I guess that would work too, but I like this way. Just easier in my head. Okay. Then, what do? We lower the procedure statements. So in this case, we've got adding two numbers together. But the problem here is we don't know where the numbers are, because I believe the problem is we're looking at identifier. Right, so it's a binary op. Where's binary op? Here, binary op. And then we're lowering the left and we're lowering the right. And it's a plus b or x plus y, which means these are going to be identifiers, I think. And if they're identifiers, it's supposed to return the symbol from the symbol table, but it doesn't seem to be doing that. So let's see what's happening at this stage in the binary op. So let's compile the program in debug mode, and we have to run the compiler. What are we running here? This is the compiler, yep. I'm just going to go down here to binary op. There we go. Let's remove the other breakpoints. And I'm just going to run this. Okay. I'm not 100% sure what we're looking at, so let's have a look. Oh, there's two watch windows. Node.token. It already said plus, didn't it? I saw it for a split second. Plus. Okay, so this is the plus in our file, which is, that's the wrong one. 09. Actually, let me go back to here and then I'll open 09. So we're definitely looking at this because that's the only plus in the whole program. So we're looking at x plus y. Let's have a look what happens when we go into here. So we're lowering. We've got a node, which is x. And now we're going to look up the value in IR symbols and return it. I should probably have separated this onto a separate line so I could see what it's evaluating to. That's probably not the right word, but anyway, let's just do it here. I call them slots. I got to make sure I say that without any weird accent that might make it sound like I'm saying something else. Okay. All right, so here is our slot. What is it? Okay, that's very wrong. So what we probably should have done is exists, something like this, or even just okay. No.token.text. Return slot, else. This is sort of a panic situation, right? If we're looking for an identifier and we can't find it, it hasn't been declared. Oh, and I know why it hasn't been declared. So I'm gonna put a panic here and say cannot find identifier. No.token.text. And I'll put the line number and the column number. I'm gonna have to make a general error printing thing at some stage to make. I want really nice errors for the compiler, like I don't know if you've ever seen the Elm programming language. I don't want to look at this. I want to look at this. So Elm is a functional programming language that's basically for writing web applications. And you can see here, this is an error message. So naming error, cannot find variable, list.nap, and then it's got the line that it's on with a line number, and then it's got these little arrows saying list does not expose nap. Maybe you want one of the following, map any, map 2, map 3, etc. So it's sort of like a fuzzy, matching thing, which is nice, and it's just a nice format. It's way better than just like, I don't know, segfault or something like you would get in a C compiler. Although to be fair, I think Clang has very good error messages these days. GCC is getting better, I think. But yeah, this is really nice. So anyhow, that's sort of the goal for later. Nice error messages. I can think of counter arguments already, but I'm not gonna worry about that. Don't know why my brain's making counter arguments to something I just said. Let's see, what have we got? We need the line number, so that's the token row. Why didn't I just call it line and column instead of row? Anyway, whatever. It's just going to confuse me forever. All right, so that's stopped. We can build the code, and if we just run this, it should panic. Yeah, cannot find identifier X. Okay, now I said I know why. And the reason is, when we process a procedure declaration, you might have noticed here, there's nothing about the parameters. So, that's kind of a problem, huh? So, yeah, right here, we're getting the name, then the shadow space, then saving RBP, then setting RBP to RSP. So this is all stuff that we need to do right first. And then now we've got to process the arguments or whatever, however you want to say that. So in this case, we're going to have a list of, I'm just going to print it out. Print line. How do I make colors? Print colors, Windows CMD terminal. Is it the same? Is it ANSI? Right. Yeah, it is. Okay. So, yeah. Wait, what? I'm pretty sure you need a prefix, right? Like an escape sequence. You can't just type this. I don't... Right? That's not gonna make a color. Isn't it like 0x or something? Alright, let's just see if this works. I'm pretty sure this is not gonna work. It's been a while since I've printed ANSI colors. So I want to print out node.data proc decal. Do I call it parameters or parameters? Okay. Yeah. So that doesn't work. Also, I don't actually need this right now because it's right here. So it's just printing the pointers. Okay, I actually want to print out each parameter. So for p in this. All right, here's the parameters that we have. We have x, which is an identifier, y, which is also an identifier. But they have no types. Interesting. Did I not parse types? Okay, let me think about this. They've got data. I don't know what type of data. Oh, yes, I do. Okay. So what do they got? They got a token. Yeah, okay. So we can do something like this. p.token.text and then p.data. And it's going to be, I can just look at it. Parameter, and then it's got a type, which is a value type and a name. Yeah, okay. I guess I'll print the whole thing. That should work. Yeah, there we go. Yeah, so we've got X, which is U32. Actually, we don't need this part because the parameter data itself has the name as well. So we've got a X U32, Y U32. All right, cool. Now we have the parameters. We can I guess we've got to add them to the locals somehow. Are they not in the symbol table? Yeah, they wouldn't be in a symbol table yet. So we've got to say something like symbols p.data.parameter.name equals. Also, we need to check for shadowing at some point. And this is going to be, well, it depends which parameter it is, which argument. So it's, what is it, RCX, RDX, R8, R9. That's the order for Windows. Now, eventually I'm going to have to support Linux as well, so this will be different. But we'll cross that bridge when we come to it. These are the Windows integer registers. Now, I'm also going to mention right now that XMM0, XMM1, XMM2, XMM3, these are the float registers. And the way that it actually works is if you pass in, like let's say your function is something like, or your procedure, whatever, is, I'm just going to write it in C notation, I guess. Int A, float B, int C. Oops, get out of there. Int C, float D. And then I'll add another one as well. Int E. All right, so you've got these alternating types between float and int. All right, so if you've got these alternating types here, then it's actually going to use, on Windows, it's different on Windows and on Linux. So on Windows, it's going to be, the first int goes in RCX, then the first float on Linux, it goes in XMM0, but on Windows, because this is in the second parameter slot, it goes in XMM1. And then this int C is going to go in R8, and then the float D is going to go in XMM3, and then this fifth parameter is going to go on the stack. Now in Linux, there's 6 parameters, I believe. I can't remember the registers, but I think you can have up to 6. So this is actually going to be RCX, and then XMM1, R8, XMM3, and then stack. So just something to keep in mind. I'll just leave this comment here. All right, so processing the arguments, which are called parameters. Which is fine. And we're going to set the parameter value to, I forgot what we're doing. Oh yeah. Well, the thing is, it depends on the types and the position. So if it's, I'm just going to do something dumb first. So I'm going to say if, hang on a second, let me think about this. So in parameters is going to be for all registers. For registers, RCX, R8, R9. Float registers, oops. I should have just typed it, it would have been faster. Alright, float registers, XMM0 to XMM3. Okay, now we can say something like if p dot, what do we have access to? It's not really like, I'm not doing real type checking yet, it's just a string. So, okay, let's just do the simplest thing possible for our current case, and then we'll worry about it in a little bit. So if p dot data parameter dot type dot kind, why is the kind none? What can they be? Flexo, welcome in. Flexo says, oh hell yeah, this is the best content. That's good. Glad you like it. So I just want to have a look quickly at the value type that we've got here. Because what is the value type kind? Okay, we've got none, slice, array, pointer. But maybe what we should have in here also is integer and float. No, we don't really need that, do we? Alright. Here's integer type. I'm just going to make this procedure. If it's an integer type, then we want to use the int register. Oops. Flexo says this looks like Rust, but it is not. This is Odin, so oh wait, which part do you mean? The one that I'm typing in or the one that I'm parsing on the left? Well, they both look similar. So I'm making the compiler in Odin, and the language that I'm making is this one on the left here. Alright, so we're going to just default to RCX because that's the first int parameter. And then if it's an integer type, we're going to say register equals int registers. Flexo says, oh, well, IG, they all look the same. What is IG in this context? Man, I'm getting old now. I don't know all the acronyms anymore. I guess? It's I guess, isn't it? Else if is float type. Yeah, thanks. It is I guess. Maybe we should actually set this to invalid register and then have some no, this should be stack. Add to the stack. Or get from the stack, rather, I suppose. That's interesting. This is going to be an interesting case to handle in a bit. Flexo says, so what do you want your language to be like? I guess you can think of it like C, but I'm not going to support a wide range of hardware, so we can make some hardware primitives visible to the programmer rather than abstracted away. And not just hardware primitives, but also operating system primitives like pages and etc. All right, so we got the float register, int register. So low level, but not like embedded C. Yeah, it's kind of, it's low level, but it's not assembly. And the idea is, the hypothesis I have is, that I want to test is, will it be easier to write correct and highly optimized programs if the known underlying primitives are brought into the language itself? So, for example, things like cache lines and pages and maybe registers, etc. I don't know about that. We'll see. See, and there's a bit more to it as well, like, guarantees about memory, reading and writing. That's a big one that I want to check. Because you can do a lot of this stuff in other languages, but it's sort of bolted on just because of the history of programming languages and most of them being very old. Hey, Beg Barros, welcome in. Beg Barros says, have you read a blog post from Sebastian Alt about No Graphics API in order to declutter access to graphics hardware instead of using such complicated graphics API like Access VRAM with pointers? I have read the article, but I think I read it when it came out and I didn't know enough to understand it. I should reread that. Yeah, he's doing some good work. I think he actually just released something recently. Someone sent me a link about him releasing a minimal graphics API of some kind. Yeah, I want to look into that, actually. Abdul says, I read it too. Frankly, I'm not good enough graphics programmer to understand it. Yeah, that's the problem that I had as well. Graphics programming is like a whole nother thing. Abdul says, but what I do know is that graphics APIs are way too complicated. Yeah. Yeah, I think so. I like Vulkan now that I got used to it, but I don't know if that's some kind of Stockholm syndrome or something. Yeah. Okay, let's have a look. So, got our parameters, we got the register, and then we say, what is stored in here? Operand. Can't remember what an operand looks like. Okay, here we go. Kind, register, value. Oh, yeah, okay. So this is a register, and the register is register. Okay, so obviously this isn't going to work for the stack yet, but now that we have these symbols, well, I'll leave that print there. We should be able to look them up. Oh, I made a lot of mistakes. What did I make mistakes? XMM3 is not... Oh, I haven't added these to register. Okay. And register has no field invalid. Oh, did I call it none? Maybe I called it none. Let's have a look. Yeah, I called it none, and I gotta add floats. So these are the SSE registers. You can do SIMD, I think. So 128, I think they're 128 bits wide. But for some reason, instead of storing it in the second lane in the same register, we store it in the other register. It's probably faster. I don't know the internals of the CPU. We're missing, in this case, the names. All right, that makes sense. We don't have these helper procedures, and also we don't have an invalid type. Yep. Invalid register, we've got none. Okay, so we need is integer type and is float type. I'm just going to put these, I don't know, at the end of this file. I think we could probably determine this at parsing time instead. But we'll worry about that later. Okay, so we want to return... I guess we can do a switch, I think. I think you can switch on a string in Odin. Switch S. Case. What have we got? S8. S16. S32. S64. And now all the same things, but for unsigned. Turn true. Now, I'm not sure if I want to have an int keyword in this language yet, so I'm just not going to do that at the moment. No, this is just going to be F32 and F64. I was almost going to do R32 and R64 because real numbers, that's what it's called in the manual, in the instruction, you know, the x64 manuals, but I think too many programming languages use F32 and F64, so rather just keep the convention. I know a lot of programming languages use I for signed, but I am going to break convention there and use S for signed and unsigned. Abdul has said some more things. Let me just read these out. Abdul says, internally the CPU has many more registers than what the assembly language allows you to use. This is a technique called register renaming, and the number of physical registers differs from CPU to CPU. Machine code is nothing more than an API that the CPU understands. The decoder changes the machine code into something completely different before execution. Oh, okay, interesting. That's good to know. Right. So we're using basically a minimum subset, I guess, that CPUs are required to support, but they could have many more. That looks good. Did we fix? Looks like we fixed this, I think. Wait a second. Add RDX, RCX, move RX, RDX. Yeah. I mean, I think that will be correct. We're still doing this, We didn't unwind the stack here. Abdul says, so when you use the RX register over and over again, that's not that bad actually because you are using multiple physical registers. Okay, gotcha. Huh. That's good to know. And I feel kind of cheated. Like, oh yeah, you want to use the hardware, then you can use assembly, but then it's like, nope. Actually, you're still using some kind of virtualization on top. Yeah. Guild Co. Hi, Mr. F. How you doing? Hope you're having a good day. Right, so why did the stack not... Excuse me, did I not implement stack deallocation at the end? Welcome in, Iana. I hope that's how I can say your name because it's very long. You say yellow. Okay, yellow is good. I like yellow. So I've got stack dealloc here, but the stack size never got... Oh no, I did do it. I'm just not reading. Yeah, and we did it here. Okay, yeah, it's working. All right, just need to use my eyeballs and read the actual code. Okay, so the last thing we need to fix is down here. We're moving into RAX, the value, nothing. So what is this? This is the return for the main procedure. Let's just have a look at proc decals up here. Right. So we're returning, let me see. I think I have a to-do in call. Yeah, that could be a problem. Okay. So that makes sense. This doesn't do anything. Yeah. So we need to actually call this procedure here. So what I'm gonna do is I'm gonna edit this code directly for a second. All right, I'm gonna do call add. So what have we done? We've moved the variables into the correct registers. We have added some space. Why did we do that here? Let's see. Right, all right, this is part of this, I guess. Hang on a second. So, all right. Hang on a second. So that's unwinding the stack. And then we call add. Probably want to not do it in that order. Begbara says, what do you think the main flaws in Odin language at current state? I don't know if I would call... Well, I don't know if I really think there are any flaws exactly. There's just some taste differences that I have. So for example, there's a lot of implicit procedures, or built-ins, you might call them, like append. You just have to know that, I mean, obviously you just have to know things about the programming language, but, you know, just reading the code, this might look like just a random function call that's somewhere in user code, but it's actually built into the compiler or built into the language. And I would prefer Zig's something like some way of denoting it. So in Zig, it would be like @append, right? That's the Zig, how Zig does it. I think multiple return values is good. I was really on the fence about that for a while. Ah, Ian. Right. Oh, it's Ian. I would have mentioned this on a previous stream, but I wasn't able to cache them. Not very good idea to attach the return statement to the function structure itself. Oh, yeah? Well, welcome in, Ian. Not a good idea to attach the return statement to the function structure. Let me see. I'll show you what the data looks like. You can tell me if this is what you mean. What I usually see done is have a single label at the end of the function assembly. Single label at the end of the function assembly. So return statements would just generate a jump to that specific label. Oh, I see. So like, actually, I don't even know how to do labels. I guess it's the same as this. Not sure. But let's just say this is the, you know, main ret whatever, and then something like this. Is that what you're saying? I think they call it the epilogue. You don't have to generate the stack cleanup at every return statement. All right. I think it's jump, says Abdul. Oh, okay. Well, jump main ret. Okay. Well, let me have a look at the epilogue page. I've got it open here, I think. All right. So prologue, epilogue exists at each exit to a function where there is normally only one prologue. There can be many epilogues. Epilogue code trims the stack to its fixed allocation size if necessary, deallocates the fixed stack allocation, restores non-volatile registers. By popping their saved values from the stack and returns, the epilogue code must follow a strict set of rules for the unwind code to reliably unwind through exceptions and interrupts. These rules reduce the amount of unwind data required because no extra data is needed to describe each epilogue. Instead, the unwind code can determine that an epilogue is being executed by scanning forward through a code stream to identify an epilogue. If no frame pointer is used in the function, then the epilogue must first deallocate the fixed part of the stack. The non-volatile registers are popped and controllers return to the calling function, for example. Okay, returning the fixed allocation size memory, pop the non-volatile registers and return. If a frame pointer is used in the function, then the stack must be trimmed to its fixed allocation prior to the execution of the epilogue. This is technically not part of the epilogue. For example, the following epilogue could be used to undo the prologue previously used. Okay. Load effective address. I can't remember what that syntax means. I remember I read it yesterday and it made sense. Let me read this again because it made sense when I read this, I think. Frame pointer that points 128 bytes into the fixed allocation area. Right, okay. So if you've got a pointer in R13 that's telling you somewhere in memory, this is 128 bytes up from that pointer. Okay. Okay. Big Barrow says, I think the main flaws of Odin is that it's difficult to know when we have to free something after call a procedure, or even if we have to handle some error. And Abdul says, in Odin, the intention is that you will use memory allocators to keep your memory management simple. It's difficult to know when we have to free something after a call procedure. Well, usually, the convention in Odin is that if a procedure allocates memory, they usually take an allocator parameter. So, I mean, I haven't written idiomatic Odin here, but it would be something like my proc that allocs, and then whatever your parameters are, and then the last one would be something like allocator, context allocator, or it might be temp allocator, depending, and then it might return something or not. But anyway, if you ever see this type of signature, that means it's going to allocate memory. So that's something to keep an eye on. So what you could do is, depending on what you need the memory for, like if it's just a short-lived thing, you could put it on the temp allocator and then clear the temp allocator. It depends what you're doing, but in a game you might clear it every frame or something. Or you could just pass in your own allocator and then clear that at some point later when it's convenient. Abdul says, I have a compiler written in C and I only have like 3 arenas that I use for everything. Oh, nice. Yeah, I'm just using, I think I'm using new. I think I'm actually just using new somewhere. Yeah, I can't remember where the function is. Here it is. I'm just allocating randomly on the heap. I'm not worrying about it right now. But I can just change the internals of this procedure later if I want to. Idle says, the temp allocator is the best thing ever. Just use it to your heart's content and free it at some convenient point in your program. Also, doesn't Odin have the context implicitly passed? Yes, the context is implicitly passed to every procedure. So in here, you can access whatever's on the context. So there's an allocator, there's a temp allocator, there's a user, I think it's called user pointer, or it might be user, I think it's user pointer, which you can just set to whatever you want. And then there's a logger, I think. I think it's logger or log. Yeah. Oh, so the point of that is if I, for example, set something here on the context, like context.allocator equals my allocator, and then I call parse file. In parse file, when I make this dynamic array here and I don't specify an allocator, it's going to use this one because that's what's on the context right now in this scope. And then once it comes back out of this scope and goes like upper level to whatever was calling parse, the context allocator will be changed back to whatever it was in the higher scope. But the reason that Gingerbill made context like this was actually to, I think he said, to intercept API calls. So it's not really, for libraries, it's not really about convenience of you changing your allocator in your own code, because you can just pass in your own allocator as a parameter wherever you want. All right, so I've decided that the Prolog stuff is too hard for me right now, so I'm going to do just whatever I feel like and not worry about what that page says, and we'll see how that goes. Okay, so let me I guess I'll save this and then I'll run the code again. And we got back to this situation. All right, that looks fine. Now this one, however, doesn't work because call doesn't do anything. So we need to actually make this do something. So make, I guess I'll just append an instruction. Abdul says, yes, I prefer the approach of passing allocators around. Yeah, me too. I remember when I first used Zig, I didn't like it, but I've come to really appreciate it now. I guess I've written some larger programs. It gives you the clarity of knowing where you're making allocations and how much memory you're using. Yeah, that's right. Do we even have a call opcode? No. Let's add that. And of course, I'm going to have to adhere to the x64 conventions at some point. I just want to see if we can, you know, get something working and build it up. So I just can't read those Microsoft documentation pages. I just don't know what it is about them. They're just not, they're not written for me. I don't understand them. Every time I read them, they're confusing. So that's fine. I think I just have to do stuff. I can't just read a page and then understand it. I got to do the thing. Ian says, it would probably be better not to focus on the stack stuff at the moment, considering you're just testing small programs. And also, Ian doesn't think the Microsoft docs are made for humans. Yeah. Well, we did the stack stuff yesterday, so that's fine. But we do want to call, and then we want to... What are we calling? I can't even remember what an instruction looks like. Destination source label. Oh yeah, label. So the label that we're going to call is... Wait, what? This is the wrong thing. No.token.text. Abdul says, and oftentimes the docs are just wrong, and the best way to know how to do something right is to reverse engineer something that you know is correct. Yeah, something that I'm going to do, I don't know, maybe soon or maybe later, is compile little C programs and then sort of compare the assembly and see what we get. Okay, Abdul says he doesn't use an assembler or a linker, he outputs exe files directly. And to do that, he had to reverse engineer Windows exe compiled with Clang. Oh, that's interesting. I would like to look into that as well because the linker is slow. But yeah, that's cool. Well, first things first, all right? First things first. All things in good time. Pretty sure Soding did something similar at some point, says Ian. That does not surprise me at all. Right. We've got a call. We've got... All right. So we're missing the call. That's been a really handy thing. I like that. Where is it? Here. So we're going to call the procedure. Did I not type that correctly? How do I keep getting git F? I don't understand. How many times that happens? Anyway. All right. So we are calling add. And then we're not moving Move RAX. Okay, good to know, good to know. Excuse me. What's going on here? All add and then move RAX. This is the return node. So the slot is going to be the expression that we lowered down. But in this case, it's actually a call. If it's a call, we don't need to do this. So, can we do something like if expression.kind equals, no, it's not expression.kind. If I need to look at what this is again. It's a node, right? No, maybe it is this. My intuition is telling me this is the wrong shape for this, but it might work. Yeah, call add and then return. Okay, well, let's just run the code. It does produce the value 42, so that's good. I'm going to run it in the debugger just to make sure. Okay, so here we are. We've got our... get out of there. So what I want to check... Go away. What I want to check here is if the stack is aligned correctly. So we've called into main, and since main calls another procedure, it's got to be allocated to 16. That's correct. I mean, not allocated, aligned to 16. That looks good. Then we copy the base pointer, the stack pointer. Yep, set up the parameters. And then we've gone back to, let me look at the memory here. Okay, so we've gone back to here, which is the return address of start. Okay, and then, I've skipped the whole call. Darn it. Let's have a look. No. God. There we go. All right. So we want to not skip the call. We want to go in and... Yeah. Hang on a second. This is... No, that looks good. Okay, that's good. So that's the return address for this call. That's the return address for the previous call. I don't know if that's... This is a leaf, so we don't need the shadow space, right? Yeah, I think that's correct. Okay. Moving into doing the stack setup, etc. I'm going to change it later so that this stack copy thing only happens if there are more local variables than parameters that are passed in. Like if we actually need the stack, because if we don't need the stack, then we're just wasting instructions. But right now, we don't need to worry about that. Okay, we're going to add the values together. Then we get 42. Move those into RAX to return them. Okay. Okay, we've gone back to this address, or we're about to go back to the other address. And cool, done. Nice. All right. This is successfully compiling and running. Let's just do another test here to make sure. What numbers should we add together? I don't know. 1000. We'll make it easy. And 500. 1500. Wow. Look at that. That's cool. Okay. Crap. I'm saying crap because we're an hour in and we achieved the goal, and I don't think I wrote down a second goal, so now I have to think of something on the spot. Let's see. Well, why don't we just test something a bit more complicated and see what happens, eh? Oh. Yeah. So, what could we do? I suppose we could just allocate random things on the stack here. See if this breaks. Of course, none of these do anything. But, oh, it broke. Good. Okay, now we have something to do. Alright. So we got back 30, which is C. Why did we get back 30? Let's run it in here. Alright. Here we are. So I moved into ECX 10, 20, 30 into R8D. Okay. Then 40 into R9D, 50 into R10D. And then we allocated some space on the stack. I'm just bring the stack pointer up. And then we put in there 0x3C. What is that? 6? Is that 60? Yeah, 60. And then we allocated more space on the stack for 70. Okay. Then we deallocated all of that. Ian says, is there a reason why you move into RSP instead of just pushing the RBP? Might have missed something. No, there's no reason. Okay, add so what's in RDX and RCX right now? Yeah, those are the two numbers. And then add them together. And now RDX is... Wait, what is 1E? 30. Wait a second. Let me start this again. RCX and RDX. 0x1E is 30. 0xa is 10. Ah, yes. You know why? We didn't mark these registers as used. So we need to actually do that. Use registers set. I don't even know if that's the right data structure. No, it's a bit set. Alright, so it's going to be an else. Alright, now we've got another error. Nice. We have something else to fix. Let's have a look. Okay. Whoops. Okay, allocate the shutter space, blah, blah, blah. Welcome in Boom Plays. Boom Plays asks, where do I start learning how to create a coding language? I already know how to code, but I have no idea how a coding language actually works. Well, there are some good resources. You can start, Crafting Interpreters is the one I was just about to mention. Thanks, Ian. Crafting Interpreters is a good start, and I'm not sure what else. You can look at how Lua works. I think they document a bit about how the virtual machine works. If you're interested in that. Let's see. All right. Okay, just a second. Let's see. What are we doing? Right, so the problem was we were overriding RCX and RDX, which we're now not doing. But now they hold pointers. That's weird. Why do they hold pointers? I gotta run this again. Call. Okay. Oh, hang on a second. This says move byte pointer onto the stack. What is the actual code that we're looking at? This. Okay. Oh, I didn't know that. Apparently Soding Daily, I know that's not how you say his name. I can't say his name apparently. Also has plenty of videos implementing / creating programming languages. Cool. Thanks, Ian. Okay, so this is not correct. Wait. I'm in the wrong... Okay, I'm in the wrong place. Okay, let's go again. Alright, here we go. Okay. So we called into main. Main sets up some space on the stack. Alright. Why are we moving stuff onto the stack here before the call? That's not what we want. Alright, this should be not this. Oh, right. I see. May need to do this on call. I think the problem that we've got here is we're saying these registers are used at this stage, but actually they're used just before the call, not at the procedure. Oh, this is the wrong place. Yeah. Hang on a second. So it should be down here. Call. Alright, hang on a second. I'm doing something dumb here. Abdul says... Oh, sorry. Begbaros asks, in your course, will you teach how to make a game using Vulkan or just Raylib? Just Raylib. We're focusing more on gameplay systems rather than rendering. Rendering is like a whole another thing. We do some shader stuff and, you know, 3D space maths and etc. But yeah, just trying to keep that part a bit minimal because it's a whole huge topic. All right, so I think the problem that we're having here is we're supposed to call into main, and then this is supposed to move values into the correct registers, not onto the stack. Why is it moving them onto the stack? Because technically we ran out of registers, even though we didn't. I guess because I never reset the registers at this point. Alright, so down here, we can say some of the registers are used, sure. So use registers plus equals register, but at the top of a procedure, we're going to say none of them are used. I think that's what we need to do. That might cause a problem, but let's see how that goes. Well, that works. But just because something works doesn't mean it's right. As strange as that might sound. That looks better. That looks better. And we're using the stack. Okay, finally, the last thing I want to check. Also, this having no new line at the end is really irritating me, so I need to change that right now. It should have a new line. I guess the label should have a new line before it. Where is it? Yeah. Okay, there we go. And we can go up to here and just get rid of that. That looks nicer. I don't know why I was alt-tab. I mean, going to the other window when it's right here. Cool, that looks better. Okay, now, the thing I want to check is the stack properly aligned at all times so far? So, it's currently aligned correctly. Is it aligned before this call? No, it's not. Did it just add this address? What is this? 09? Is that... Right. So, whoa. Hang on a sec, guys. My monitor just turned off. I can see it on OBS. On the other monitor. Okay, there we go. I really need to change the cord. I'm using USB-C for my monitor, which is just not great, apparently. Alright. So I think this is only coincidentally working. I don't think you're supposed to have the address aligned. I think it's always supposed to be pushed to this side because the stack is meant to be aligned. Let me just check that in the calling convention. Is it calling convention? Welcome in Peace Gaming. Is this how C++ was made? Abdul says no, C++ was made in a dungeon of trolls. Yeah. All right. Yeah, so I don't really understand the docs. It says stuff like things will be and things must be, etc., but then the code runs correctly, so I don't know what to believe. But anyway, yeah, so type storage is going to be kind of useful, I guess. I mean, I already know this stuff. Well, I should look at it anyway, just in case. Yeah, makes sense. All right, so right now we don't have any... We're not really worrying about alignment of types because we don't even do type checking. I'm sorry if I mispronounce this, but Yuvra... Can I call you Yuvra? Yuvra Jane? Welcome in. Why are you building a programming language? Because I want to test some things about programming that require a new language. I guess what we could try... Actually, I don't think this is correct at this stage. So just before this call, we are... Why are we doing that just before the call? Unwinding the stack back 40, but then it's not aligned, and it doesn't have the shadow space. Oh, but this doesn't need shadow space. Alright, so I'm gonna show my lack of skill in a second here, because I'm gonna need to do some alignment arithmetic, and I always struggle with this. Doesn't matter how many times I do it. Doesn't matter how many arena allocators I write, I just can't get it through my head, apparently. So, what I'm gonna need to do is, before a call, there's already a note here, align the stack to 16, right? So before the call, we're gonna have to check what the stack is. So at the moment, I'm just gonna print something out for a second here. Print line. I'm gonna print the stack offset. I just want to get an idea of what that is at every point. And we're gonna have to look at this code up here somewhere. Okay. Here it is. So, minus 40. And then, well, that's it. Because that's the only call. Okay, that makes sense. So, at that point, it's minus 40. Which means when we add 40 back, it's going to be aligned to $16. No, it's not, because we called into this. I'm confused now. I'm looking at the wrong procedure. All right. Abdul says, isn't it just num padding bytes equals current stack size mod 16? I think so. Or could that truncate it? Yeah, no, that should be correct, yeah. Yeah. All right, I'll just do that. I'll just do this. So where is this procedure here? Stack alloc. I should probably check. Oh, that's not where I wanted to go. I wanted to go to where I just did something. There it is. So I could just say something like if stack offset mod 16 is not 0, then, as you say, padding bytes, and then Let me just try this. I think there's probably something wrong with it, but we'll have a look. Yeah, it's definitely wrong. That's why it's crashing. What do we actually do? Excuse me. So... Right, yeah. Wait, what? I suppose it should be negative. Ian says, seeing these streams is slowly steering me into trying out Odin. It's a pretty nice language, I will say. It's quite nice. Did you just output the padding bytes? It should be padding bytes plus current stack size. Says Abdul. I'm not sure what you mean by that. Did I output it? All right, so we do have an error now. So let's have a look. I just want to, oops. Okay, so we're going to look at the stack pointer again. Here it is. Okay, etc. Okay, now we've unwound the stack. There's the return address for this procedure, but we're about to call. Okay, and then we allocated some space, and then we added, yeah, we added this. Yeah, correct. But I think now the problem is when we return out of this, okay, the return is going to work. And now the stack is deallocated. I mean, not deallocated. We need to deallocate the 8 empty bytes here. So that means we need to basically just, okay. Should align false. Oh, I guess I could do this. Stack. Should align. Okay. It's always going to be 8, right? But I'm just going to write here bytes added, just in case. Or padding bytes, I guess I'll call it. Oops. How do you replace things? Replace word? No. I haven't used Vim in a while. Whatever. Okay, padding bytes, and then we can just say here, dealloc padding bytes. Alright, maybe not the most efficient assembly code, but I think that should now hopefully satisfy the convention of keeping the stack allocated to 16 byte boundaries. Ian says the whole stack growing downward thing always scrambles my brain for some reason. Same. Like if you saw the stream, the last stream or the one before, they were both about stack allocation. I was just getting confused over and over again. All right. I keep pressing the wrong hotkeys. Cool. So now that's the return address for this procedure. That's the return address for the previous procedure. So we'll just go through this, do whatever it is that we're doing. Okay, we got the value out back into RAX, return, good. And now, yes, deallocate the stack and return again, return. Cool. Ian says, been meaning to ask, but what is the debugger you're using? I'm using the RAD debugger. RAD debugger. It's made, I think, primarily by 2 guys. And I'm forgetting the second guy's name. Alan Forth, Mr. Forth, I think, and Ryan Flurry. I need to... It's been a while since I've looked at... I'm sure it's Alan. Yeah, but I'm sure there's other people who worked on it. Alan Webster, that's right. Thank you. Thank you, G. Fieldar. Also, welcome in if you just got here. Also, I didn't just fart. I don't know if you guys heard that, but the leather was squeaky. Anyway. Fourth, like the programming language? No, I think it's like Fourth Dimension or something. I remember him talking about his, how he came up with his name. It was like a little kid and he spelled dimension wrong with a T. And then he just kept it. I think it's... No, I don't want you to do that, Google. Maybe I'm misremembering or misattributing this. Okay, well... Yeah, Alan Webster. He also made the 4Coder editor. I don't know if you guys have seen this. But yeah, as far as I understand, he is responsible for a lot of the debugger before Ryan Fleury seems to have taken over the project now. I'm not sure if there's other people working on it. I don't know the internals of the company or anything, but that's just what I've seen. It's a free debugger actually, so Abdul says RAD debugger is the greatest thing that happened in the systems programming world in a long time. Yeah, it's good. It's good. Before RAD, I was using Remedy. I don't know if I have it installed on this computer, actually. I don't even have it installed. Remedy is really good as well. It is a paid debugger. And as much as I really enjoy this, and I think it's a really good product, I would say, well, you kind of get most of, well, maybe all of what RAD debugger currently has. All of what this has in RAD debugger now. But it might not be the same now, but for a while, there were some programs that I just couldn't debug in RAD, so I had to use Remedy, and Remedy was working for everything. So if you want a good debugger, this is also another option. And if you want to support someone who made one as well. I can't remember this guy's name now. Ian says, the few times I've had the displeasure of debugging compiled programs, I just raw dog GDB, so I might have to check it out. Yeah, I'm not a huge fan of GDB personally. I find it's very powerful, and the user experience is, in my experience, not good. But there are some useful things, like I was using it the other day. There's a register view, which, I mean, you can just... There's a register view here too. Right, you can see all the registers. But, wow, there's a lot of registers. Anyway, yeah. Good stuff. I like debuggers. Very nice. I'm just gonna get rid of that. Ian says, I say displeasure because the only time I debug stuff like that is due to memory errors. Right. Yeah, they can be pretty hard to figure out sometimes. But that's what debuggers are good for. And G Fielder, excuse me, or is it G the Elder? It's G the Elder, of course, G the Elder. Sorry, it's just all lowercase, so there's no like, anyway. G the Elder says they are close to getting RAD working on Linux from what I understand. Yeah, I've heard that. Yeah, almost makes me want to use Linux. Well, I do use Linux every day on my laptop, but yeah. Problem is, if I'm going to make games, then 96% of the market is on Windows, so Makes sense to at least test the games on the native platform that you're deploying to, right? All right. So, did we get all that working? I think we did. That's cool. Chief Sosa says real. I assume you're talking about testing things on the platform. All right. What do we want to do now? I might have a pee and have a think, and also get another drink. Targeting windows? Yeah. Abdul says, I found a good thing to do on PC is to allocate more space than what you need up front, so you only have to worry about logic errors rather than memory bugs. Then you can think of a better memory management strategy later. Yeah, that definitely works. I made a video about this, but something that I think is really broken in programming education is we teach people to think about memory allocations as if you're only ever going to have one thing. Like, oh, you have one node, and then you have one node, and then you have one node, and then maybe these have, if it's OOP, a node has like functions attached to it, or methods, whatever you want to call them, and then fields, etc. Right? But in reality, you know, you're building something, whatever you're doing with a tree, you're going to have like n nodes. And so if you need to reclaim that memory, like in the compiler, I don't care right now because I'm just outputting the program and exiting, so I don't care about reclaiming the memory. But let's say we wanted to compile millions of lines, we might want to reclaim some of that memory, which means we'd have to use a grouped allocation strategy. So we say, oh, well, we want to handle n nodes, so we're just going to either allocate thousands or hundreds of thousands or whatever up front, and then add more if we need them, and then just clear them all in between files or in between sub expressions or however you want to do it. Rather than like, oh, we've got this giant tree. Okay, let's walk the tree and like, oh, we've got to deallocate this one. And then we've got to go up. And then we've got to, oh, are these ones deallocated? I don't know. Let's go down and deallocate these ones. It's just ridiculous when you could just store them all in the same block and then just deallocate the block, right? Anyway, that's my little rant. I could rant about this for hours. Yeah, definitely broken. Abdul says, in my compiler, I literally just have a dynamic array of nodes where I predict upfront based on the average source file how many nodes I should allocate. Yeah, exactly. Now, right now, I think I covered this just earlier, but I'm not doing anything. I'm just calling new, which is, this is the single allocation strategy I was just talking about. But since I never deallocate anything and I don't care right now, this is fine. But later, if I'm, as I said, parsing tons and tons of source, I might want to do something different, but this is okay to get started. The thing is, when people use this as the, you know, the end-all solution, and then they, yeah, I don't want to, I just said the same thing. I was about to say the same thing that I just said, so I'm not going to say it again. Okay. All right, be right back. I'm going to grab another drink. Maybe you guys can suggest something that we could work on next if you feel up to it. Otherwise, I'll try to think of something as well. All right, let's have a look. Well, I didn't think of anything because I was thinking about food. Seems like you guys are mostly talking about memory allocation. All right, that's fine. We could try supporting floats. Just see if that works. I don't know if we parse them properly. Let's try. F32. Actually, do I even have to specify? Let's see. Actually, I'm going to make a new fixture. Not going to return anything, I guess. Just going to say f is 0. Not f. X is 0.5, y is 1.0, and that's it, I guess. I don't really have anything to do with this. I suppose I could add them together. Alright, cool. I need to shave. My hair's getting a bit long. Believe it or not, I used to have very long hair. Well, not very long, like that long. Just past my shoulders. Long time ago now. Alright, wrong fixture. Cool. This is a Odin compiler crash, or are we in an infinite loop in the compiler, in my compiler? Ooh, infinite loop in my compiler. Okay. That's cool. Why is that happening, I wonder? Every now and then the Odin compiler crashes, and that's usually hangs for like 2 seconds. Happens to me, I don't know, maybe like 5% of the time, something like that. Maybe a bit less than 5% of the time. Although I haven't updated for a while. Build, code debug, there we go. But it's usually fine, you can just run it again. I think it's something in LLVM actually, but yeah. Let's have a look. Where are we getting? Well, I'm going to run it, and then it's going to spin, and then I'm going to pause. Where are we? Uh-huh. Alright. Ian says, I love when my determinism machine is not deterministic. Yeah. Yeah, weird, huh? How do they do that? Okay, so in this case, we're just failing to parse something on row 6, column 9. I don't think we pause periods. So let's have a look at that. Do we actually which procedure were we in? Were we in the lexer or the parser? The lexer. All right. I don't think I have a dot. I don't even have a dot anywhere. This is a number though, so how did I... Is number current token... Yeah, so we're not handling floating point numbers at all. I think I could just do this. Abdul says, I learned the other day that the MSVC compiler is not deterministic. Every time you compile your program, it uses different registers in each function. Because of course it does. Yeah. Alright, there we go. So, yeah, obviously this is not correct code, but did we get numbers at least? Let's have a look at the tokens. Number 1.0, good. That's a number. Where's the other one? 1.0, 0.5. Okay, cool. Alright, so we got the numbers. They are floating point numbers though. So when we do parse int somewhere, here it is. We've got a, why does it say fix me? It's fix me with no note. Ah, silly me. Okay. Alright. I'm gonna actually change this a little bit, I think. Oh, whatever. I'll just do it here. Strings contains. I really don't like this. We probably pause it wrong so it says fix me. Yeah, maybe. So I'm gonna actually no, I'm gonna, let's see, for is num, blah, 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 do advance. Instead of that, I'll say if is number, do advance. Just gonna separate these out here. Or, if we've got an underscore, that's fine. But if we've got a period, I want to do something else. I want to advance. Hang on a second. Do advance. This is annoying. This is the wrong way to make this. Whatever. I can fix the look of the code anytime. Just want to make sure it's correct. So if we've got a period here, I want to say something like is float false, and then here we have break, I guess. That's such a dumb way to write this. Whatever. Why am I doing this in the tokenizer? See, this is the... I'm not going to do this here. Whatever, it's just going to be a number. I'll do it here. I'll scan the text. For rune in string, if r is period, then so if it's a float, we want to do a different string conversion than if it's an integer. Of course, we're going to also have to handle... I'm going to put a fix me here, actually, or a to-do. Handle 0b, 0x, etc. Parse float. I think parse float is a procedure. I don't parse float. Actually, I need to look it up. That's not the right. strconv. Parse float is not a thing. Okay. Parse f32 is a thing, and parse f64 is a thing. Okay. So. Here's a question if you guys are making a programming language that's targeting x64 and your main domain is video games where you almost always use float 32, would you make the default float value 32 bits or 64 bits? The simplest rebuttal to function is too long is to say that these things have to happen in sequence. You can either have that code here or in another function, and in most cases, I'd rather have it here. All right, so Abdul says he hasn't figured it out. Ian says they'd rather have it in a third secret thing that gets converted when convenient. And Vibin says 32. Yeah, so I think I know actually, in Odin, there's an untyped float. Here it is. Untyped float will implicitly convert to any numeric type that can support fractional parts, including float 64, quaternion 128, etc. And then there's untyped integer, and there's untyped string and untyped boolean. I think this makes a lot of sense. Abdul says 32-bit by default. If it's a narrowing conversion, it should require a cast. Ian says the literals should be the highest bit length possible. Yeah, you know what I want? I want someone to explain this line. I've read this line before. It says, the autocast is only recommended to be used for prototyping and quick tests. Please do not abuse it. But it doesn't say why. Why not abuse it? Why please do not abuse it? Is something bad going to happen to the compiler if you abuse it? Ian says the float literal should be 64 bits, but the type should be 32, if that makes sense. Yeah, so what I was thinking of, well, is basically having a similar thing where a number is just a number. Well, maybe not a number is a number, but a float is a float. Can fit 64 bits, I suppose. And then as soon as you use it, like in this case, you pass it into this procedure, right? And then this takes an F32, so it's coerced into an F32 here, right? And so Z is an F32, X and Y are untyped floats, I think. Welcome in, Joe. Is this the daily hangout? I suppose so. Abdul says, probably because of truncation bugs. You're referring to this, yeah? Yeah, I just think this is weird. It's just weird phrasing to me. Please do not abuse this feature in our compiler. I don't know. I need a reason why. Can't just say don't do this. You have to say why not to do it. Ian says, yeah, you don't want the literals to be too small, otherwise you might get precision issues and be scratching your head as to why. Abdul says, yes, the autocast. Oh, yeah, you were talking about autocast, yeah. So I think we're going to have basically, yeah, untyped floats as well. I think I'll just totally take that. And so these will be float 64s for now. Joe says, don't tell me what to do. Don't put it in the language then, YOLO. Yeah, that's exactly how I feel. Like, if you're going to tell me what to do, you're going to tell me why. You can't just tell me not to do it. You're not my parent, All right, not my dad. Ian says, also, I think they say not to use AutoCast because it's bad etiquette to just use it everywhere. I suppose, but they didn't say that in the docs, or in that documentation, so... yeah. I can only speculate, which is the problem. Okay. So, if this is a float, we get a number... num is... oh, that's kind of a problem. Hang on a second. This is not going to work unless I transmute it. I guess I could do that. But this doesn't have a... whatever. I'll just put a F64 here. Alright, so this can be if... okay, do this, which is going to be vt.float equals num, and then here vt.length equals num. Whatever. We need to do this error parsing number. So that should, there should be an error. Okay. This is so dumb. Okay, that's fine. So we paused, and etc. Abdul says, the new Odin inline assembly stuff is very exciting. We finally have assembly as a first-class feature in a language rather than something that's bolted on. Yeah, that is cool. I haven't looked at it yet. But in theory, cool. Very cool. The compiler actually understands your instructions so it can give you proper errors. Oh, that's cool. Yeah, I like that. All right. This is incorrect. All right. Well, that's interesting. It did use float registers. Then it... oh, that's something I need to look at. What's the return? The return register for floats. Is it still RAX? I mean, it's just a 64-bit register, right? But it's returning XMM0. Okay. Right. So, that's interesting. This is going to be incorrect. That's cool, though. So, did we get any numbers in here? It doesn't look like we got any numbers. We got 0 and 1. That's definitely not right. So if it's a float, then we convert to F64 and assume, well, let's just test if this actually worked. Ian says you could have a trailing union that contains the concrete values in the value struct, both the float stuff and whatever else kind of literals you may have, instead of just storing the int value in the length for some reason, question mark. Didn't catch that in a previous part of the stream. Also, I don't see why there needs to be separate designated float registers. It's all just bits in the end, lol. Yeah. Well, that's not my decision. Yeah, I could have a union. That's correct. I think the part you might be missing is that we're not trying to build a complete polished program from the beginning. We're trying to figure stuff out first. So that's why things are a bit weird. I'm not trying to, you know, show you like, oh, this is the best way to do something. I'm just trying to get stuff done. Right, so I want to go in here. Whoops. Is there no... Wait, is it in the... Oh, it's in the parser, isn't it? Okay. Alright, here we go. So let's have a look at this. Nope, that doesn't even... We never even get to this point. Oh! Yeah, I'm totally editing the wrong part of the code. Whoops. Well, I think. Let's have a look. Parse value type. So this is the return type. This is the parameter type. And what's this? Struct. Let's see where we parse variable declarations here. Then we parse the expression. Okay. Ian says the union thing is just something to keep in mind for later. Right, yeah, sure. That makes sense. Alright, so got all these operators, then we're going to parse expression LBP, if that was P, so we're going... Hang on a second. Hang on a second. Okay, we've got to look at parse nut. Oh, here it is. Here it is. So this only handles ints, right? That's the problem. So we should probably make a parse number procedure. That's not one of these parse procedures, but we're going to take in, I guess, the text. Return. Well, I guess we want to return is float or integer. I mean, int and i64 is the same, so whatever. Excuse me. So basically we want to do the same thing here as we did down here. So if we have a dot, then it's a float. I know it's a bit crude, but I think that makes sense. Wouldn't have a dot in any other kind of number. And then if it's a float, we're going to do... Right, why did I not just copy the rest of this? Oh, and we also have to... we don't have to, but that could be our okay. Did parse equals true, float equals number, and this one is integer. Joe says maybe add a to-do for locale handling for floats so you can check for commas. Right. Commas? No, I'm not going to support commas. What is this? I'm going to use commas in numbers? That's crazy. We can use underscores in numbers, but definitely not commas. That's some European thing. Or is it American? No, it's American, right? Commas. Text. Okay, I actually want to return. Joe says, no, I think it's Northern European. Really? Oh, for decimals? I don't know. Right, not for separators. So, American, numbers, large numbers. I kind of actually like this, even though we don't do it in Australia. In Australia, we just type the numbers like this, so you've got to squint. It's kind of nice to have the separators, but yeah, for what you're talking about is like 0.5 with a comma rather than a dot. So that would be half, right? Yeah, I don't think we need to worry about that. Joe says, I know this because we ran into a bug with GLB importing when a user on Linux changed their operating system locale. Huh. That's weird. So GLB supports that, huh? But that was a C issue. All right. Where was I again? I was parsing numbers somewhere. I'll search for parse int. Okay, so here we need to parse a number. I can't remember what the return values are. Okay, so we get back is float, integer, did parse, and then we just pass in the text. You guys are on C99 and C89, huh? Wow. Ian's on C23. Don't worry, by 2099, C23 will be widely adopted. Yeah. Okay, so just gonna get rid of that. And we don't need any of this. I guess we need some of it. If is float. VT dot. I know it seems weird that the length field has the number. It's because, I'll show you why in just a second here. Because when I was creating this, I was looking at arrays. So I was actually creating somewhere to put the array length. So I came up with this value type thing. So that's why it has a length rather than a value or something. I could probably just change the name of this or have a union, as Ian said, rather than overloading it. But that's fine for now, I think. So we've got that. That one's done, but the other parse int, not that one, this one. We need to handle this case. All right. If did pause getting hungry. Getting hungry. I'm probably going to complain about getting hungry for a few months. Until I start increasing my calories. Did pause. Hopefully not a few months. Hopefully like 1 month. Maybe a month and a half. Begbaros asks, is it possible to use inline assembly templates in Odin to program the GPU instead of using graphics APIs? I don't know, but I don't think so, because you need to get access to the registers in, well, not just the registers, but you would need access to the memory and cores in the GPU, which are all locked behind proprietary drivers. So that's why we need to use shader programming languages. Okay, so if we did pause, then are we doing this? What are we even doing here? Right. N.data.number. I see the problem. Okay, so a number is only handling an int. But the problem here is we've just made a number. Oh, gosh darn it. Okay. Or I could extend the number node to have a kind of number. Probably want to do that, actually. But now I've got to update this everywhere, which is going to be very annoying. All right, let's do it. Where is it? Number is int. No, it's actually a struct, which can be... Do we want a raw union? Maybe we actually want a normal union for once, and we can have float 64 or an int. Ian asks, speaking of C weirdness, did you guys see that Clang implemented a defer for C a little while ago? Huh. I didn't know that. That's cool. Defer is nice. Okay. Let's see the compiler errors. Chief Sosa says, didn't GCC have defer since like forever? In the form of... okay, I'm going to write this out on the stream. In the form of this. I mean, maybe, I don't know. If you're going to extend the language, you might as well make it nice, not whatever that is. Alright, so we can't assign a union to an int. That makes sense. Yeah. Alright, so in IR, 295, 290, yeah, right here. Whoops. God. Dang, damn it. Alright, so right here, we're going to have to do a switch on the node. V in node dot dot is a number. I think. So maybe I shouldn't do it this way. Case int, then do this. I don't know about that. It's also incorrect, apparently. Cannot assign float64 of type float64 to int. Oh, yeah. So, immediate... this value is an int. Can I just transmute this? I know it seems ridiculous. We're just copying the bits into it, right? So we shouldn't actually have to care. About the type at this stage. Which I guess means we could do that here. Now that I think about it. We could just transmute it into an int at this stage and then not... But we might need to... No, we need to know the type later. Yeah. Because we need to put it in a different register. Alright, 403 in the parser says... Right, yeah. Alright, sorry, there's a lot of stuff going on in the chat. The problem with most languages is that they have 200% of what you need, says Abdul. The problem with C is that it has 50% of what you need, and then Ian says 50% is a bit generous. Yeah, I kind of agree with that. And then Abdul says, and the problem with C++ is that it has 500% of what you need. Yeah. Yeah, a little bit. Okay, are we getting real numbers? Not yet. No real numbers yet. Because... That's weird. I thought this would work. What's wrong with this? Transmuting it. Should just copy the bits, right? Oh, I know the problem. When I emit the number, wherever that is it somewhere here? Yeah, here it is. I cast it to a number. Chief Sosa says, what features does C lack? What do you guys think? I mean, it's a complete programming language for sure. It'd be nice if it had some things like strings. Oh, yeah, as Abdul says, generics, pretty useful. Module system, yeah. I don't like header files, that's for sure. But that's not something that it lacks. That's something that it has that I don't like. Joe says first-class function pointers. Tagged unions. First-class tagged unions. Oh, man. There's no way to tell if this is a float at this point. Because the operand doesn't encode that data. Oh. Alright. Alright. It's gonna hurt. I'm just gonna put float as an extra type. Ian says the type system is weird and it's only recently catching up, but not supported by any compiler yet. Abdul says good support for metaprogramming would be good too, but if it just had the quality of life features that Odin has, I would be happy. Yeah, I agree with that. If we're going to have a float kind, we might as well have a float value. Actually, this should still work. This should still work. Hang on a second. What the... Alright, we're still not getting floats. Not getting floats because... Oh, I've been streaming for 2.5 hours. Well, I want to finish this verse. Ian says, I would say operator overloading, but then look at C++. Value equals 8, value equals 40, value equals 1. So here it is. It's immediate, so that's wrong. That is incorrect. How is that happening? So the instruction is apparently an int. Abdul says in Java you just say print %, some struct, and the compiler does that completely safely, and you don't even have to specify the type because the compiler knows it. Yeah, well in this case I'm actually not using the right type, so I could probably do that actually, because Odin has that feature as well. So why don't we do that? I'm just going to have to do something with the instruction. It's either going to have a, I guess the operand is going to have, can we go to the operand? It's going to have a float type, I guess. No, everywhere is going to have an extra 8 bytes of memory. Whatever. All right, now let's see what's broken at the moment. Actually, 64. So here we can say float is this, kind is float, value in this case is int, that's fine. Now, how did nothing break? That's crazy. Okay, but when it comes to emitting, should be able to do this. Hang on, that's not going to work. That wouldn't work anyway, because we need to emit the hex value for floats, right? Also, this is float. What's going on here? I feel like this isn't even being hit. It's not. We're never getting a float. No float operands. At all. So let's make a simpler program. I'm going to just delete this. Delete all of this. Alright, there's a really simple program that doesn't even make sense, but whatever. So it's an immediate. That's wrong. Okay. So why is that wrong? That should be this case. F64. I'm just going to... I'll use the debugger. What am I doing? So I need a break at IR296. Oh, my stomach is rumbling. All right, let's have a look at this. All right, so we got up to this point. Let's have a look at the node. What are we looking at? We're looking at a node 0.5. It's got a kind of number. Yeah, that's right. And it's got data, number. It's got the tag 2, which is a long. Well, that's wrong. So this is incorrect at this point. So we've paused it, and we've somehow output the wrong number. Let's have a look. Oh, we never set isFloat. Wait, no, we did. IsFloat is true. IsFloat, etc. So I guess we probably want to check at this point. All right, pause. So not here. We want to actually have the breakpoint at, where is it? Pause number, this one. Yeah? Nope, not that one. This one. Here we go. All right, here we go. So we got back. Oh, my stomach is rumbling. We got back. Let's look at the locals. Is float true? There's the float. And did it pause? Yes. All right. So if it's a float, we set the number to the float. Is that what we're going to do? Let's have a look. N.data.number. Yes. So I've set the number to 0.5. I'm stupid. Look at this line here. Look at this line. And then yeah. Didn't delete the old code at the end. Where is it? Yeah. Okay. Now, obviously, this doesn't make sense. I don't think. Pretty sure it needs to be hex, right? Or can you actually type floats in assembly? Ian asks if I'm assigning a float to an integer. I mean, kind of. It's all just memory anyway, right? Chief Sosa says, well, they were talking about the history of C and how everything in the 1970s was so different. So the idea of a programming language built from the ground up for modern platforms is exciting, yeah. The assembler should be able to understand floats, says Abdul. Okay. Well, I mean, that's the wrong register, I suppose. But, let's see what we can do. All right, so wow, Tamim. Hello, welcome in. How you doing? What do I even want to do? Oh, I could probably just undo all that and then add this back in. Have a look at that. All right. That's looking better. This is, I guess that's correct, except obviously these registers are wrong. So RCX and RDX, yeah, because I hard-coded that, I think. For the parameters. Huh. How do I check if it's a float type? From the type name. Oh, but this is only for parameters. And so in this case, when we're setting up the call, where do we even do that? I guess we don't do it there. We do it in vardecal. So lowering the node. And it's now stored as a symbol. Alright, so I've got to check something here. So when we call add, we move the parameters that we want in. Where do I do that? Am I blind? Chief Sosa says, video of Casey's talk at this year's Better Software Conference has been released. Oh, cool. I should check that out. Wow Tamim asks, are you developing software? Yes, I'm developing a programming language, which is a kind of software. But I'm getting very confused right now because I can't remember where I set up the parameters. When did I do that? Procedure statements, check for shadowing. Okay. So procedure declaration. This is at the start of a procedure declaration, and then process the arguments. That's not why we set it up. Is it just a coincidence that these are in RCX and RDX because they're the first? I think it's a coincidence. Let's do this. Yeah. Okay. Doi. There is nothing that's putting the parameters in the correct place. Okay. Whoops. So that's done. I'm going to write a new to-do here. I'm going to say set up the arguments into the correct registers. We also need to save any locals in those registers to the stack, and then restore locals after call. Okay. I think I might have to call it there, guys. I think this will be our goal for tomorrow. So I thought we are going to get function calling done. I mean, it sort of works by accident. But as you can see, it was just a coincidence. So what we're going to do tomorrow is actually set up the arguments to be passed in to the correct registers, call the procedure, and also save the locals, restore the locals, and we'll get floating point working as well. Might also do a little bit of a code cleanup tomorrow. Some of the code's getting pretty nasty, so that could be a thing. If you've been enjoying the streams, I want to thank you very much for tuning in. And thanks everyone for asking good questions and helping me out. I appreciate that. Yeah, we're going to try to develop, well, my plan is to develop the whole thing on stream. Hang on, am I connected? It says I'm disconnected. I think it might have cut out for a second there, but if you didn't catch that, I just wanted to say thank you guys for tuning in. We're going to continue this on every weekday and sometimes on the weekends, and try to get the compiler into a state where we can write programs in the next couple of months. That would be ideal. All right. Yeah, I am actually going to go now, though. It just cut out, but I'm going to go. So, yeah, thanks, guys. See you later. Have a great day. Oh, it's been cutting out a few times. I pay for like fiber to the premises, and I have a Ethernet cable directly plugged into my computer. Whatever. Australian internet. Okay. Anyway, see you guys.